Welcome to this explainer. Today, we're diving right into the architectural essentials you need to master for the AWS DevOps Professional exam. There's a ton of material out there, so we're going to ruthlessly distill exactly how these technical mechanisms and integrations actually work together to build robust systems.
Here's our blueprint for today. We'll start with compute and container architecture, move horizontally into the CI/CD pipeline suite, and then wrap it all up with application security and governance.
All right, let's kick things off with Section 1, Compute and Container Architecture.
We're setting our baseline here with AWS Lambda. And honestly, this is a real game changer because it's the ultimate pay-per-use event-driven compute solution. AWS handles literally all the memory, CPU, and networking resources for you. You don't access the underlying server or customize the operating system, which is incredibly freeing. You're going to use this when your architecture demands functions that trigger automatically in response to events. Things like S3 bucket modifications or API gateway requests, scaling instantly from 0 to thousands of concurrent executions. Building on that whole serverless concept, we have AWS Fargate. Think of Fargate as bringing that exact same zero infrastructure magic straight to your containerized workloads. It provides dedicated kernels, memory, and CPU for your tasks, guaranteeing complete isolation. You just specify your CPU and memory requirements in your task definition, and Fargate provisions exactly what you need: zero server management overhead.
Now, when you contrast these two launch types, it perfectly frames a scenario you're absolutely going to see on the exam, deciding when to decouple infrastructure management from container orchestration. With the EC2 launch type, you're the one responsible for the instances, the scaling, the patching, and you pay for those provisioned resources whether your containers are fully utilizing them or not. But with Fargate, you shift that entire operational burden to AWS, and your billing is strictly tied to the exact vCPU and memory your containers actually consume.
Okay, so it's also absolutely crucial to distinguish between your orchestrators. You'll want to go with EKS when you need that standard Kubernetes compatibility. Like if your organization already uses Kubernetes on premises and you want a seamless migration without rewriting code, EKS is for sure your perfect answer. On the flip side, ECS really shines for deeply integrated AWS native microservices. ECS uses straightforward task definitions and natively hooks into services like application load balancers and CloudFormation with incredible ease.
Tying this whole compute layer together is Amazon Elastic Container Registry, or ECR. This acts as your durable storage repository that integrates seamlessly with ECS, EKS, and even Lambda. A super interesting architectural detail to remember for the exam is that ECR utilizes Amazon S3 on the backend. That means you get that incredible 11 nines of durability. Plus, it encrypts your container images at rest using AWS KMS.
Moving right along to Section 2, the CI/CD pipeline suite.
So, AWS Code Pipeline. This is the tool that orchestrates your entire release process through these highly configurable stages. It's basically the grand conductor of your code. A code commit in your source stage automatically triggers the build stage to compile. If that succeeds, it flows right into testing and finally into deployment. And the real beauty of Code Pipeline is that it integrates natively with AWS services, or you can even pull in third-party tools via custom action providers, like plugging in an existing Jenkins server for your builds.
Diving a little deeper under the hood, we see AWS Code Build. This acts as the scalable, fully managed CI engine working inside those build and test stages. Code Build is what actually compiles the source code, runs your unit tests, and produces the deployable artifacts. And because it's fully managed, it scales automatically to process multiple builds at the same time. That means your developers are practically never stuck waiting in a queue for a build server to free up.
When it is finally time to push that code, AWS Code Deploy gives you these specific deployment models. And you definitely want to memorize this matrix for the exam. Notice how all at once involves briefly taking your application offline, so that's generally restricted to EC2 or on-premises environments. But then look at blue/green. This is the gold standard for zero downtime. Traffic is dynamically rerouted at the load balancer level, and importantly, this is the exact method you'd use if you're updating AWS Lambda functions or Amazon ECS services.
But beyond just moving code around, Code Pipeline actually acts as a massive governance checkpoint. It's not just some automated fire hose. You can inject manual approval actions, say pinging a manager's phone via SNS to halt a deployment until they review the code. Plus, for those strict enterprise environments, Code Pipeline employs AWS Private Link. That ensures your pipeline's traffic can communicate securely with your VPC resources without ever touching the public internet.
Which of course raises a really critical question for anyone designing these high-velocity systems. You've built this CI/CD pipeline that pushes code to production in minutes, but speed without guardrails? That's dangerous. So how do you make sure this automated marvel isn't deploying vulnerabilities or just immediately getting knocked offline by a DDoS attack?
And that brings us to Section 3, Application Security and Governance.
So AWS WAF, the Web Application Firewall, serves as your frontline defense right at the edge. By hooking WAF directly into Amazon CloudFront or your application load balancer, it literally intercepts malicious traffic before it ever touches your compute layer. It's actually pretty amazing. You can deploy AWS managed rule sets to instantly protect against SQL injections or cross-site scripting. And critically for modern setups, WAF implements API rate limiting. If a bad actor tries to overwhelm your Lambda-backed API with thousands of requests a second, WAF simply drops that traffic right at the edge.
Now, while Wave guards the front door, AWS Trusted Advisor is acting as your automated internal auditor. It's constantly scanning your deployment for configuration flaws. It practically looks over your shoulder, evaluating your entire AWS environment against established best practices, making sure your automated pipelines haven't inadvertently created a weak link somewhere inside.
It is super fascinating to see exactly how Trusted Advisor categorizes its findings. For instance, if a deployment accidentally leaves an S3 bucket wide open to the public or opens SSH ports to the world, the security check flags it immediately. It also actively looks for cost optimization, pointing out if you have provisioned massive EC2 instances that are just sitting around idle. This lets you tighten up your architecture and your budget at the exact same time.
Seeing this whole unified ecosystem come together is honestly pretty incredible. It's not just a bunch of isolated services. It's understanding how AWS Code Pipeline seamlessly utilizes code build to create a container, pushes it securely over to ECR, and then deploys it to a serverless Fargate cluster using a blue/green code deploy strategy, all while AWS WAF stands guard at the edge.
So, before we wrap up this explainer, let me leave you with this scenario to test your architectural intuition. If your automated CI/CD pipeline pushes a bad configuration to Fargate, who actually catches it first? Is it Trusted Advisor? Or maybe a WAF rule? Figuring out how these overlapping domains interact when things go wrong is where the real fun begins. Thanks so much for joining me on this explainer. Keep exploring, keep building, and I'll catch you in the next one.